Our topic for today is about the requirements for chemical equations. On the end of this lecture, we will know what are these requirements for writing a chemical equations. Number 1. The equation must identify all the reactants and products involved in the reaction. Have a look on this reaction below. In here, we are properly identifying the reactants and the products. The reactants and the products are separated by a single arrow. This arrow is indicating the direction where the reaction will proceed. On this example, the reaction is proceeding from left to right, while the reaction below is indicating that the reaction is proceeding from the right side to the left side. A plus sign is placed between the reactants and the products as required. We are also using a double arrow for reversible reactions. Reversible reactions are the reaction which can proceed either from left to right or from right to left. The second requirement states that the equation must contain the correct formulas for the substances involved in the conditions required to carry out the reaction. Have a look at this example. In here, we are writing the correct formulas of the substances. We also use the subscripts S, L, and G, which stands for solid, liquid, and gas respectively, to represent the state of the substance as shown below. We mentioned that the equation must contain the conditions required to carry out the reaction. Have a look at this example. This reaction indicates the application of heat to carry out the reaction. The delta sign over the arrow may also indicate the application of heat. This basically means that we needed heat in order to produce the products that we have in the reaction. The third requirement states that the amount and ratio of reactants and products must clearly be shown. Have a look at this example. A chemical equation must show the smallest number of atoms, molecules, or ions that will satisfy the law of conservation of mass. The law of conservation of mass states that the atoms are neither created nor destroyed in a chemical reaction.